Alright, these are day 2 that we are redoing. On the division, we're going to do synthetic, but we're missing a term. Notice that the x squared is missing, so we'll put a 0 there. -5, -12. Whenever you're doing the division, you do the opposite of what's in the parentheses. That's what you're dividing by. So drop down the 6. 2 times 6 is 12. Add that up. 2 times 12 is 24. 24 minus 5 is 19. 2 times 9, that would be 38. And 38 minus 12 would be 26. That would be the remainder. Alright, number 12. Find side x. Here's the angle right here, 35 degrees. The hypotenuse is the longest side. The x right here is on the adjacent side. That means that this is cosine. The cosine ratio is x over 5. That means you're going to put that over 1 and cross multiply. When you do, always put the 5 first. Cosine 35. And put that in your calculator. So 5 cosine 35 gives me 4.1. Even if you round it, it'd still be 4.1. Number 13, they want to know if there's any solutions to the polynomial below, and they want to know p of 1, -1, and 3. So we're going to put this in the calculator, and we're going to find each one of these. So we go to y equals, and we put in 3x cubed minus 5x minus 9. Alright, so if you hit graph, you'll see what it looks like. Ooh, let me zoom out of that. Zoom. Standard. Alright, that's much better. Oh, only one solution there. That's not any of those. Alright, so we'll look at our table. We want to know p of 1, -1, and 3. So p of 1 is -11. P of -1 is -7. And p of 3 is 57. Again, none of these are the solutions, so I'd say none. And you could tell by looking at the graph that solution is right there, and it should be pretty close between 1 and 2 on your calculator. You'd have to hit the trace, second trace, to get that answer. Okay. Number 14. Write a polynomial function that has the roots 4, that would be x minus 4, -3, x plus 3, and -1, x plus 1. And the dominant term of the coefficient is a positive 1, so you could put a positive 1 if you want. That's what the equation will look like. That's all they're asking. Number 15, find the inverse if this is the original function. The inverse would happen when you traded those places, so that -3 would come first, the -5 would come first, and the -8 would come first. It just means the x and y trade places. Alright, number 16. What are the zeros of the polynomial function graphed above? Well, there's a 0 here, and that 0 is at -1. There's one here at +1, and there are 2 at 2. So, x is equal to -1, x is equal to +1, and x is equal to 2 twice. Or if you just listed them, -1, 1, 2, 2. 17, find the x-intercepts. So the easy ones are the ones that you see in the parentheses, -3. There's 2 of these, 1 and 1. This is the tough one. Whenever you see an x that stands alone, know that that is 0. So there are 4. It's a quartic. Number 18, let f of x and g of x equal those, and find f of g of x. So that means that you're going to plug this in for x. So 2 times -1, plug in the 3x, 2 times 3 is 6, done. Alright, we're ready to move on. Number 19, Let f of x equal, let g of x equal, find f of x minus g of x. So 1, negative 1 minus x squared minus negative 1 plus 2x. Go ahead and rewrite this with taking care of the negative, so it's plus 1 minus 2x. And a negative 1 and a positive 1, these two cancel each other out. And so you're left with a negative x squared minus 2x. Alright, last one, number 20, find the domain and range. The domain, our x, is greater than or equal to 3. Our range, y, is greater than or equal to negative 1. You could also do interval notation, 3, negative 1. However it looks on the test, you're going to want to match it. That was day 2.